Hi, welcome. We are doing notes 3-7 today on page 54. So open up, come on with me. We're going to be talking about perpendicular lines. Now, you know the lines are perpendicular when their products, the products of their slopes is equal to -1. So if you multiply the two slopes together and you get an answer of -1, you know that those lines are perpendicular. Or you can look at the slopes and see that they're opposite reciprocals. And if they're opposite reciprocals, they're going to be perpendicular as well. So we're going to check this. We want to know if these two lines are perpendicular. They look like they're probably perpendicular. Again, but you don't know for sure, so you have to calculate it and make sure you know actually. This point right here is 0, 3. And this P they told me was right here is the decimal answer. I need to find the slope of that line first. So I'm going to call this line 1. If I want to calculate the slope of that first line, if you remember the formula for slope, it is y2 minus y1 over x2 minus x1. So we're going to do, I'm going to start here with 3 minus the negative makes it a plus 0.6. I'm going to start with 0 minus the negative makes it a plus 1.8. Here I get 3.6 over 1.8. That's exactly half. So I divide that and I get a 2. So the slope of this first line is 2. Now I need to calculate the slope of the second line. So the second line here, this point that I know for sure is going to be -3, 0. So when I go and calculate the slope of line 2, I end up, I'm going to start with the 0 minus -0.6, so plus. So minus a negative makes that a plus. Then I'm going to start with -3 minus a negative makes it a plus 1.8. So here I have 0.6 over -1.2. Again, that's exactly right. So we have a -1/2. So I can multiply those together. Positive times negative will be a negative. The 2's will cancel, giving me that -1 product. Also, these are opposite reciprocals. So opposite reciprocals are opposite signs, and a reciprocal is where you flip the fraction. Okay, so this over here, yes, this one is perpendicular. I'm going to check this one over here. Now this one, I don't really have to calculate slope because I can see two distinct points. If I can see the two distinct points, I'll just count them. So I'm going to count the slope of this line, rise over run. Remember, slope is also rise over run. I'm going to count 1, 2, 3, 4, 5 over 1. So that is a slope of 5. Now this next line, slope of line 2, I go down 1. This one's a negative slope. So immediately I can put my negative here. I go down 1 over 1, 2, 3, 4, 5, 6, 7, 8. Okay, those are not opposite reciprocals. This is not perpendicular. So there you go. You can calculate those. Counting is the easiest, but if you can't count because it's some weird point, you can always use slope. Okay, so we want to determine here if we have the lines. Determine if the lines are perpendicular. Go ahead and pause your screen. Decide if you think those are perpendicular or not. I need to look at the slopes. So first, I want to check this. I am isolated. The y is isolated. If the y is isolated, you are now in slope-intercept form, which is y equals mx plus b. So if we're in y equals mx plus b, we want to look at our slopes. Here's slope of the first line, slope of the second line. Now, these are reciprocals. They're flipped, 2 over 3, 3 over 2. But are they opposites? They're both negatives. So these are reciprocals. Not opposite. So these are not perpendicular lines. Okay, so over here, these y's are not isolated. This is not in slope-intercept form. So I either need to calculate the slope somehow or put them in slope-intercept form to see. I'm going to solve for y here. It's 7y. Add the 2x over. I have to divide by 7. So I can see over here that the slope of this first line is going to be 2/7. I have to do the same thing over here. Solve for y. I get 2y equals, I'm going to subtract 7x over, plus 10. Now I need to divide by 2. So here, when I divide, I get a slope of my second line is negative 7/2. These are now opposite reciprocals. So yes, we are perpendicular. Okay, another thing that I remember too is if I am in standard form, so if I'm in standard form of an equation, my slope is going to be negative a over b. So the opposite of whatever a is, which would be 2, over 7. There we go. Opposite of a, which would be negative 7 now, over b, which is 2, negative 7 over 2. So if you just remember this, you don't have to solve for y each time. So it's kind of a little shortcut if you want to remember that. Okay, I want you to write an equation for a line that passes through a point and is perpendicular here. So you need to write an equation. I'm going to start with that. I like to start with the ghost formula of a point and a slope. So I'm going to start with y minus, again, pause. Do you know this? Do you have this equation memorized? Can you write that out? Y minus equals m times x minus. So I write it like this, where I leave the 3 blanks that I need to fill in, and immediately I know it's going to be this point. So I can go ahead and put my 4 in here because that's my y. Remember, your orbital pair is x, y. And I'm going to put my 3 over here with the x. I need my slope. So I come back over here. I want it through this point, and I want it perpendicular to this equation. Do you notice here that this is not isolated? Remember, you have to isolate your y. So I'm going to divide both sides by 3. I get my slope here originally is 1/3. Okay, now I don't just want my slope, I need the perpendicular slope. So my perpendicular slope is going to be the opposite reciprocal, so negative 3 over 1, or just negative 3. Now, I'm done. All it said was write an equation. Any equation you want of a line, and that's going to be the easiest one, so I'm done. If it told you specifically what equation to write, you could then solve that for y and put it in slope-intercept form, but it doesn't ask you here, so you're done. The slope of a line perpendicular to lines, the slope of one of 2 perpendicular lines is a over b. What's the other one? So the perpendicular slope is the opposite reciprocal. So this is positive, it'll be negative b over a. There we go. We're going to go to page 2. If you can, go ahead and solve 7 and 8 and come back and watch us in the notes. But can you do those ones on your own? Or even any of these down here. Pause and do whatever you can. Okay, so first thing here, I have this equation here, represents a mirror. A ray of light hits it at this point. What is the equation of a line that is perpendicular to the mirror? Well, here's my equation. First, I'm going to identify the slope. What is the slope of that equation to begin with? And it's 5/3. Now, I want it to be the perpendicular slope. So it's going to be the opposite reciprocal. And I want to write an equation again. So I write my ghost formula for the equation y minus equals n times x minus. And immediately I can put in the point before I even did any other work. 1 goes to the y, 3 is with the x, and I just found my perpendicular slope is negative 3/5. So good job if you're ready to write it that way. Now find a value of k so that a line through these 2 points is going to be perpendicular to this line. Okay, so I want to find the value of k. I don't want to write an equation here. I need it to be perpendicular to this line. Well, the slope here to begin with is negative 2. So what is your perpendicular slope? Opposite reciprocal, so it's going to be positive 2 over 1. I'm going to flip that over and make it 1 over 2. So I need this to have a slope of 1/2. I'm going to plug these into my slope formula. It's going to be k minus negative 2, 5 minus negative 3. So this down here is actually 8. I need this equal to 1/2. There's different ways you can solve this, so you may have done it already and got it a different way. You could cross multiply to get rid of the fraction. So if this is 8, I'm going to cross multiply this over here by 2. 8 plus 2, 5 plus 3 is 8 times 1, I get 8. I could also now divide both sides by 2 again. So that was kind of an extra step. I end up with k plus 2 equals 4. Subtract and I get k equals 2. Okay, good job those of you who got that. If not, and if you're struggling with any of these, remember put sticky notes, highlight, come to office hours, or ask after our main part of class. Okay, this should be some algebra review about how to simplify radicals and what they mean when they look different ways. If you have a square root of 9, there's an invisible 2 out here. That's the same as writing this as 9 to the 1/2 power. Square root of 9 is 9 to the 1/2 power is 3. So this one over here is technically asking us for the cube root of 64, or 64 to the 1/3 power. So you could put that 1/3 into a calculator and get the answer. If you don't know your cubes, maybe write them off to the side. Hopefully we know our squares and are getting pretty comfortable with that. We use them often, but our cubes here. So if I wanted the cube root of 8 is going to be 2. What is 3 cubed? 3 cubed is 27. So the cube root of 27 is going to be 3. 4 cubed is 64. Cube root of 64 is going to be 4. 5 cubed is 125. So the cube root of 125 is 5. 6 cubed. These are probably the most common ones that you might see would be up to 6. 6 cubed is 216. And another one that kind of comes up randomly every now and then is the cube root of 1000. And that's going to be 10. So these are just different ones that maybe you want to become familiar with or know that you've seen and recognize. So the cube root of 64 is going to be 4. Again, if I write it this way, the a is the power, and the b down here is your root. So here, if you saw a problem like this, 27 to the 2/3 power, you could work this out. This means the cube root of 27, which we know because that's a perfect cube, and then I want to square it. So the cube root of 27 is 3. 3 squared is 9. Okay, so we usually ask these types of questions on our tests in class. There are things that you want to look for. Every time you have these radicals and fractions, you want to look for perfect squares. So right away, here I see a perfect square immediately. This is basically the square root of 3 over the square root of 4. We know the square root of 4. This is square root of 3 over 2. Now, I also want to look at something like this. Do we have something where we can divide right away? We can simplify immediately. 35 and 7, I can reduce that by dividing. So 35 divided by 7 is going to be square root of 5. I do want you to pay attention to something like this though. Let's say we had something that said 2 over 16. Well, I could reduce that, but wouldn't it be better to just take the square root of 16 first because it's a perfect square? So if I do that, I get square root of 2 over 4. Because if I had that reduced as 1 over 8, then I'm going to have to do something like this. Does anybody remember what we're going to have to do in these cases? This is called rationalize the denominator. And if I simplified this to 1/8, I would have to do that to get to my final answer. So it's easier to look at the perfect squares. So kind of pay attention to that and how much work is your step going to create. So this we want to rationalize the denominators. When I rationalize the denominator, it means I am going to multiply by that denominator. I'm going to multiply by the square root of 3 over the square root of 3. The reason I'm doing this is 5 times 3 is 15, and 3 times 3 is 9, and I know the square root of 9, so I'm going to write root 15 over 3. You want to rationalize the denominator because you want to get rid of the radicals. No radicals in the denominator. This is the multiplicative property, multiplicative identity. So if we're multiplying by root 3 over root 3, that's 1. I'm not changing the value. I'm just changing how it looks to get the radical out of the denominator. So every time I do this, I'm going to multiply by root 6 over root 6. I end up with 1 times 6 up top is 6. 6 times 6 is 36. Square root of 36 is 6. So you don't have to write that stuff. Over here, rationalize the denominator and multiply by root 3 over root 3. I get square root of 6 over 3 times 3 is 9. Square root of 9 is 3. Every time that's going to happen because you're getting rid of the radical. Okay, so again, you want to make sure you practice those and you know how to do those. Copy and angle. We're going to do a construction here. So those of you who have your tools, pause and go get your compass and protractor. The way I'm going to copy an angle is first I'm going to draw a ray. Doesn't matter how long, you want it probably longer than that ray. So I start with a ray. Once I start with a ray, I'm going to go to the original angle, and I'm going to make an arc that is going to intersect both rays. So I come over here to the end of this ray, and again I'm going to make an arc that's going to intersect. If there was the other ray, it would intersect both of them. So my third thing, I don't know what number I'm on, 3. Now I need to come back here and I need to measure the distance from the points where they intersect the rays. So I'm going to mark here that distance. Then I'm going to come over here and I want to mark the same distance. So if I know where that distance is, I can now draw a line from the vertice point through that, and I just copy it. Okay, I'm going to pause, go to the next page. If you can set up anything on the next page and complete it, go ahead and start that. Okay, so one thing that I would do with these problems is I shade the angles. I shade the angles so I can see immediately the vertical angles that are going to be congruent. I can see if it's obtuse, all the obtuse are the same, all the acute are the same. So I don't really have to remember the rules if I can see it in the picture. So I usually always shade it, and I shaded the angles up here. So I've got to write an equation they gave me 5 and 6 here. I know 5 and 6 have to be equal. They are both acute angles. So I'm going to set these equal to each other for my equation. 4x squared equals 11/4 minus 2x. Okay. Then it wants the theorem or postulate. What is the relationship between 5 and 6? 5 and 6 are alternate interior angles. So parallel lines right now. So because the lines are parallel, I know that alternate interior angles are going to be congruent. So that's the theorem. Okay, so if these are congruent, this is x squared and this is an x, I probably want to set this equal to 0. I'm going to go ahead and put 4x squared plus 2x minus 11/4 equals 0. Now typically, I would tell you in a situation like this to clear your fraction and get rid of that fraction, that you don't really want to work with a fraction. But if this is x squared and x, I'm probably going to need to use quadratic formula in a minute, and this is my c. If you remember the formula, it's minus 4ac. So that 4ac is going to let you cancel that 4 out. That's the only time you're going to use it. So it's not going to hurt to plug this in and keep the fraction in this problem. So try to always do that. Think a few steps ahead. Do you want to clear a fraction? Do you want to get rid of it? What's going to make it easier for you in the long haul? And if that's my step, I'm going to be able to get rid of this. I'm going to plug this into my quadratic formula. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. So I sing it to myself every time. Plug them in. B goes here and here. A goes here and here. C goes right here, negative 11/4. And the A was a 4. It's going to cancel regardless. I'm going to work on the discriminant first. 2 squared is 4. Negative times negative will be positive. 4 times 11 is 44. I get square root of 48. A perfect square factor that goes into 48, well, 4 goes in, but you want your biggest perfect square, so you can use a 4, but hopefully you guys see that 16 also goes in. So 16 times 3. If you used a 4, then you had another one in there, 4 times 12, so you could do 12, so simplify 12. And you should end up with the same answer as 4 root 3. I'm going to go back over here, say opposite of 2, plus or minus 4 root 3, all over 8. So again, we've been doing it different ways, depending on what device you're putting the answers into. You can simplify here everything by 2. So I would end up with negative 1 plus or minus 2 root 3 all over 4. Negative 1 plus or minus 2 root 3 all over 4. You could also write it separately. 1 over 4 would be negative 1/4 plus or minus 2 root 3 over 4 we could simplify as root 3 over 2. So both of those are actually the exact same. Going over to the next problem. So again, set these up if you can on your own. These two, 5 and 8, are different colors. That means one's acute and one's obtuse. They can't be equal. Looking at them, I know they can't be equal. They're going to be supplementary. So I'm going to add these together and set them equal to 180. So my original equation would be 3x plus 2 times 2x plus 5 plus 3x squared minus 19x plus 106 equals 180. So this is already in standard form. I need to multiply these together. So you can multiply these by using FOIL. Some people like to use this box. You may be seen this box before, where you would have like 3x and 2, 2x and 5. So this is another way you could do it. You get 6x squared plus 4x, 15x, and 10. So you can multiply those together. Again, you can use FOIL if that's what you're comfortable with. But after I multiply them together, I end up with 6x squared plus 4x and 5x plus 19x plus 10. Now look, I want to add that to this right here. So you can write it all out. I'm going to put it above each other. I'm going to do 3x squared minus 19x plus 106 9x squared. This divides out, or subtracts out, plus 116 equals 180 degrees. So this doesn't have an x squared and an x. This just has the x squared. So I'm going to try to just solve this for x. Subtract 116, end up with 9x squared equals 64. Now I'm going to divide by 9. I end up with x squared equals 64 over 9. This is really nice because they're both perfect squares. So when I go and put in my square root, remember, this is absolute value of x equals 8 over 3, which means, don't forget, plus and minus. My answer here is going to be plus or minus 8 over 3. Okay, so that one is a little bit tricky. There's a lot of work. There's a lot of steps. So again, I strongly encourage, like, come back to this. Cover it up. Can you set it up? Can you work it out again? Do you have the process down where you're remembering all the steps? Okay, these are other review problems. Now, I know that Mr. Christensen teaches this differently than I do, so I'm not sure. He probably introduced this the first time. I always look at this as a square root, so this is 2 out here. I need all of my exponents to be divisible by 2. So I kind of change how I write the equation. If it was a 3, I would need all my exponents to be divisible by 3, so I'm going to change how the equation looks, or the expression looks. So 10 is divisible by 2, so I can keep x to the 10. Y to the 7th is not. So I'm going to instead write this, instead of the 7, I'm going to write y to the 6, and then I'm going to put that extra y over here. So that's still y to the 7th, I just separated it so it's going to be divisible by 2. Z I can't do anything with, so I keep my z here. Y is already w to the 4th, already divisible by 2, so I keep that. So I end up doing this. Anything that is divisible by 2, I divide by 2 and I take to the outside. X to the 5th, y cubed, w squared. So I square rooted them, I took the square root of each of those, divided by 2, and then whatever's left under, I keep underneath the radical. So that's how I do those problems every time. Again, there's different methods, so whichever method works best for you is completely fine. Construct a line parallel through P, construct a line through P parallel to L. So again, this should be review. Hopefully you guys remember and can do this on your own. I'm going to draw a line that intersects the first line and point P. Now, the second thing I'm going to do is I'm going to come now put an arc on the angle that I have created. An arc here. I'm going to copy that arc on that top P. Now remember, you need the arc to go far enough that if you had the second line, it would intersect it, and we did. I come back here and I'm going to measure the distance of the arc from the two rays. There we go. I'm going to come back up here. Now I have to flip this around, put the point on the original line, and come down here and mark. It's always awkward with my left hand. Okay, so once I have that point marked, I can now draw my line through P and that intersection. So I just created a line parallel to the original. I can show that by drawing my arrows. And these are a bunch of review questions that show up. So this wasn't the notes for today exactly. These were just review we wanted to go over. They show up on tests and things like that, so they're important to know. And also we wrote down here, if hypothesis, then conclusion. If P, then Q. Just kind of things to help you remember some of the parts that we've already covered. Inductive reasoning is a pattern. Inductive reasoning is observation. Our other type of reasoning was deductive, and deductive reasoning uses facts. So just kind of some quick review. Hopefully everything went well. A little bit over a half hour, apologies. It was about 10 minutes a page. I'm trying to make it shorter. Have a great day, and I will see you next time. Have a fabulous day.